Now let us go for the next question. Here the set is defined as set of all integers, and this is denoted by the letter Z, and the relation is defined as x minus y is an integer. If x comma y belongs to R, then x comma x also belongs to R. In the sense, x minus y is an integer, then x minus x equal to 0 is also an integer. Thus this is reflexive. Going for symmetric check, we need to prove yx also belongs to R. If x minus y is an integer, y minus x is also an integer. Let's say I am considering x comma y as 2 comma 7. Then 2 minus 7 is equal to minus 5, which is an integer, and 7 minus 2 equal to 5 is also an integer, and hence R is symmetric. Whether it is transitive? Of course, going by the same example, if I am considering 2 comma 7, 2 minus 7 is an integer. And if I am considering 7 comma let's say 11, 7 minus 11 is also an integer. And taking the first element and second element, 2 comma 11, 2 minus 11 is also an integer. Note that we need to take only integer for x, y or z. The reason being, we are considering only the set of all integers, not the real numbers. So thus, this is reflexive, symmetric and transitive as well. Hence it is an equivalence relation. Now let us go ahead with the next question. So these are the relations given in the book. We need to prove if it is equivalence or if it is reflexive or symmetric or transitive. The set is defined as human beings in a town at a particular time. And relation here is, first relation is x and y work at same place. It is reflexive because xx also belongs to this relation, because x and x work at same place, which is true. It is symmetric because if x and y work at same place, then y and x will also work at same place. Whether it is transitive? Yes, it is transitive, because if x and y work at same place and y and z work at same place, then x and z also work at same place. Now the next question or next relation, x and y live in the same locality. This is reflexive because x and x live at the same locality. This is symmetric as well, and also it is transitive. Now the third one, x is exactly 7 centimeter taller than y. Whether xx is possible? No, because x cannot be taller than x. Whether symmetricity is possible? No, because if x is taller than y, y cannot be taller than x. Whether transitivity is possible? If x is taller than y and y is taller than z, then definitely x is taller than z. Now the next relation is x is the wife of y. It's obvious x cannot be the wife of x itself. And symmetric, if x is the wife of y, y cannot be the wife of x because y should be the husband of x then. Transitivity, if x is the wife of y, y cannot be the wife of z. Not possible. Now, X is the father of Y. X cannot be the father of X himself or herself. Symmetricity, if X is the father of Y, Y cannot be the father of X. Transitivity, if X is the father of Y and Y is the father of Z, X cannot be the father of Z, but X can be the grandfather of Z. Thus, transitivity also fails.